You are welcome back to this channel. So in today's class, we want to study the sum of the first n term of geometric progression. As explained in the previous video, geometric progression is the list of numbers in which the consecutive terms increase or decrease by multiplying or dividing by a constant. And that constant is called common ratio. That common ratio is usually denoted with small letter d. Now, suppose the first term is a and the common ratio is small letter d. The sequence of GP will be a, comma, AR raised to the power 2, then AR raised to the power of 3, and so on till we get to second to the last term, then the last term. And the last term is the same thing as the nth term. The formula for nth term of GP is A multiplied by R raised to the power of n minus 1, where L is the last term, and it's the same thing as the nth term. A is the first term. R is the common ratio. And n is the number of terms. Series is the addition of terms of sequence. So all these terms of a sequence, if we add them together, so it gives series. So series, let's denote it with S subscript n. So the first term plus second term plus third term plus fourth term plus till we get to the last term, n minus 1. So that is series. Now, if you now multiply this equation, let's call it equation 1. So multiplying equation 1 by R, equation 1 by small letter r gives, so we are going to multiply both sides by r. So r multiplied by S subscript n is equal to AR plus AR squared plus AR raised to the power 3 plus AR raised to the power 4 plus plus ARN. Let's call this one equation 2. Now, subtract equation 2 from equation 1. So subtracting equation 2 from equation 1. So we have S subscript n minus R S subscript n is equal to, if you, this one will cancel, this one will cancel, so everything will cancel, then we'll be left with A minus AR raised to the power n. Now, Sn is common too, so let's call this one equation 3. Sn is common here, let's factorize Sn out. So we have S subscript n into brackets 1 minus R is equal to, let's factorize AR, A minus 1 minus R raised to the power n. Now, let's make S subscript n the subject of the formula. So S subscript n is equal to A to brackets 1 minus R raised to the power n divided by 1 minus R. So call this one equation 4. So this equation 4 is the sum of the first n term of geometric progression. provided that this r is less than 1, because the denominator cannot be 0. If the denominator is equal to 0, that means that equation will be undefined. So you have to be careful. If you want to solve it, you should make sure that the r is less than 1 for this particular equation. Now, another one is that when you subtract equation 1 from equation 2, so subtracting equation 1 from equation 2. So equation 2 is r Sn then minus Sn. So we have a r raised power n minus a. So here let's factorize Sn out. R minus 1 then is equal to factorize a r raised power n minus 1. So make Sn the subject of the formula. We have into bracket Sn minus 1 divided by r minus 1. So that is another one. They are the same. The difference is that 1 will be r greater than 1. And so for equation 4, so if you want to use equation 4, that means absolute value of r must be less than 1 for equation 4. That is, if you want to use this one, Sn to be equal to a1 minus r raised power n over 1 minus r. That means r must be less than 1. So if you want to go for this one, S subscript n is equal to a into bracket r raised power n minus 1 over r minus 1. That means the absolute value of r must be greater than 1. So you have to be careful because the denominator must not be equal to 0. If the denominator is equal to 0, so that equation will be an undefined. So that is that. And also, if r is less than 1 and the number of terms tends to infinity, so let's see what it's going to give us. So if it's less than 1, Sn is equal to a into bracket 1 minus r n over 1 minus r. Now, and if n tends to infinity, that means r raised power, so it will give us s infinity is equal to a 1 minus r raised power infinity over 1 minus r. And anything raised to power infinity will be equal to 0. So we have s subscript infinity to be equal to a into bracket 1 minus 0 over 1 minus r. So s subscript infinity is equal to a over 1 minus r. S subscript infinity is the sum of infinity of series. So we have three equations, three formulas for the sum of the first n term of geometric progression. So examples. One, find the sum of the first 6 terms of GP 90, 30, 10, 3 whole number 1 over 3, and so on. Solution. The first term here is 90. So we need to find the common ratio. And the common ratio will be the second term, which is 30, divided by the first term, which is 90. And this one is equal to 1 over 3. 0 cancels 0, 3 here, 1, 3, 9, 3. So we can see that this 1 over 3 is less than 1. So that means the absolute value of R is less than 1. So the formula that we are going to use will be the sum of Sn is equal to A into bracket 1 minus R raised to the power of n, everything over 1 minus R. That is, R is less than 1. So, and n that we want to find will be 6. So that means anywhere we see n, we're going to put 6. So S subscript 6 will be equal to A is 90 multiplied by 1 minus 1 over 3 raised to the power of 6, everything over 1 minus 1 over 3. S subscript 6 is equal to 90 multiplied by 1 minus, let's find the value of 1 over 3 raised to the power of 6. So 1 over 3 raised to the power of 6 is equal to 1 over 729. Everything over 1 minus 1 over 3. So S6 is equal to 90 multiplied by, so 1 minus 1 over 729 is equal to 728 over 729. Everything over, what is 1 minus 1 over 3 is equal to 2 over 3 is equal to 89 whole number 71 over 81, everything over 2 over 3. So we can simplify this one further by saying that this is 89 whole number 71 over 81 divided by 2 over 3. So this one is equal to 89 whole number 71 over 81 multiplied by 3 over 2. 89 whole number 71 divided by 81 is equal to, so multiplied by 3 divided by 2. So the answer gives is equal to 134 whole number 22 over 27. So therefore, sum of the first 6 terms of GP 90, 30, 10, 3 whole number 1 over 3, and so on, is 134 whole number 22 over 27. So that is how to find that one. Example 2. Calculate the sum of the first 5 terms and the nth terms in the series 4 plus 8 plus 16 plus 32 plus so. Solution. Now, the first thing is that the first term is 4. So we need to find the common ratio, which will be the second term divided by the first term. And the common ratio is equal to 2. So it means that the common ratio R is equal to 2 and it is greater than 1. So the formula that we are going to use for the sum of the first n term of GP when R is greater than 1 will be equal to S subscript n is equal to A into bracket R raised to the power of n minus 1. Everything divided by R minus 1. Now here we have known A, we have known R, and we have known N. N is equal to 5. So anywhere we see N, we're going to put 5. Is equal to, and A is equal to 4, to brackets, R is equal to 2, raised to the power of 5, minus 1, everything over 2 minus 1. So S subscript 5 is equal to 4 into brackets 2 raised to the power of 5 is equal to 32 minus 1, everything over 1. S subscript 5 is equal to 4 multiplied by 31. So S subscript 5 is equal to 4 times 31. So 4 times 1, 4. 4 times 3, 12. So 124. So the first 5 terms, the sum of the first 5 terms of this series is 124. B. The sum of nth term will now be equal to Sn is equal to A multiplied by R raised power n minus 1, everything over R minus 1, since R is greater than 1. So we do not know the value of n, so we'll write it back. So it's equal to A is equal to 4, R is equal to 2 raised power n minus 1, everything over 2 minus 1. So here S subscript n is equal to 4 multiplied by, so we want to expand this one, by n minus 4. S subscript n will now be equal to, so let's go to law of indices. So 4 is equal to 2 raised power 2, so multiply by 2 raised power n, then minus 4. So S subscript n is equal to 2 raised to the power of n plus 2 minus 4, and that is the answer. So the sum of nth term of this series is equal to 2 raised power n plus 2 minus 4. So that is the answer. So let's stop here. So we continue from another example in the next video. So thank you and God bless you.